In this lesson, we're going to discuss how to find the zeros of a polynomial function. Right? This is chapter 3, section 4. All right, the main idea of this lesson is, I had just mentioned that this lesson we're going to find the zeros of a polynomial, but we've kind of done part of this already, but there's going to be some scenarios in which we can't use our normal factoring methods to find our zeros, right? Now, in the previous lesson, we learned about something called the factor theorem, all right? Now, this is, this basically said that if I had a factor, x minus k, and I chose to do my synthetic division with k up here, the rest of my coefficients here, and then I did my synthetic division, I did that process, right? And then I ended up with 0 as my remainder, then I could say that this x minus k is a factor of our original function f of x. All right, that's actually going to help us today with finding the zeros of any polynomial, right? Whether it's factorable or not, right? And you're going to find that a lot of these we're not going to be able to factor like we've done in previous lessons. All right, so this is going to be a helpful tool for us to be able to find our solutions of our polynomial. All right. Before I start this, I just want to say I think there's a little bit of a typo in here. This really should say this x equals -3 is a 0. Or if they wanted to say that it was a factor, then you can say x plus 3 is a factor. Right, so in general, just so you guys are aware, I might have done this in the previous lesson, I can't remember, but let's just say I gave you x minus k is a factor, right? That just means the exact same thing as x equals k is a 0. And that's also the exact same thing. This might not come up as much as k comma 0 is an x-intercept. All right, so all of these mean the same thing, just so you are aware. There's not going to be a set way of how we're going to phrase it in a question, but you should be able to know what all of these mean, right? So if I give you x equals a number, that just means that that's a 0, right? If it's x without an equal sign, and it's like x plus something, x minus something, then you're saying that that's a factor, right? But they all mean the exact same thing. You just have to be able to conclude what the next step should be, right? So in this case, our goal is to factor this polynomial, right? And to factor this polynomial, just by looking at it, you guys aren't able to factor this the ways that we have done in previous lessons, right? So you can't really group it, right? I know it's 4 terms, but you can't group it just because when you take out a GCF, right, there's no matching factors or anything. So we kind of have to do synthetic division to get a remaining polynomial, and then we factor that as much as we can. And you're going to notice that that's the kind of the process that we're going to have to do in this lesson, right? So given x equals -3 is a 0, that just means that when I do synthetic division, right, like I said in the previous slide, when I do synthetic division with -3 in that box and my coefficients right beside it, that I'm going to get 0 in as the remainder, right? So let's actually verify that that's true, right? I'm going to bring down the 6, bring up the 6 times -3, which is a -18. 19 minus 18 is 1. 1 times -3 is -3. 2 minus 3 is -1. And -1 times -3 is 3. And the -3 plus 3 is 0, right? So we do get that it's a 0. So we already have that is one of our factors. So I have that x plus 3 is one of our factors, right, in our factored form. Right, now whatever we have left over is going to be the 6, the 1, and the -1. Now, if you remember from the previous lesson, these are going to be the coefficients of our quotient. So it's going to be a 6x squared plus x minus 1. All right, so that means this f of x, so far we have that it can be written as x plus 3 times 6x squared plus x minus 1, right? And if you even try to distribute that x and distribute the 3 and then combine like terms, you will get this as your answer, right? Now we just want to make sure that it's completely factorable, or I'm sorry, completely factored, right? So let's just check this quadratic on the inside, right? Quadratics are very easy to check, right? All you have to do, if there's a number in front, first times the last, I need factors of -6 that add to a 1, and that's a 3 and a -2. All right, so this is factorable. So we're going to keep factoring it to get that this polynomial in, to get this polynomial in fully factored form, right? So then this is going to become an x plus 3, and then an x minus 2, right? And because there's a number in front of that x squared, I'm going to divide both of these by 6, right? And then 3 over 6 becomes a 1/2, slide the 2 in front. 2 over 6 becomes a 1/3, slide the 3 in front. And then we get a 2x plus 1, and then a 3x minus 1. And then I can bring down this original factor of x plus 3, right? So that means this is our polynomial in factored form. So we just took something that was what we would consider unfactorable, right? Because we can't really use our standard factoring methods to factor something that looks like this. And we actually broke it down into factors, right? So powerful stuff in this lesson, because this is actually going to help us with the graphs of these polynomials, and it's going to help us find all of our solutions, right? So it's good stuff to know how to do, right? And to be able to factor this in ways that we haven't been able to do before. All right, so let's try the exact same thing with the next one, right? This time we're given, right? This one doesn't have a typo, right? X minus 1 is a factor. And again, an equivalent way of saying this is if you set this equal to 0, we get x equals 1 is a 0. They mean the exact same thing, but I'm just going to use the x equals 1 in our synthetic division, right? Remember, in x minus k, you're always going to use the k, right? Don't carry the negative with it if it's a factor. So I'm going to have a 1 in that box, and I'm going to have a 2, a -3, a -5, and a 6. All right, bring down the 2. 2 times 1 is 2. -3 plus 2 is -1. Times -1 is -1. I get a -6. Times 1 is -6. And then we do get a remainder of 0, right? Which is exactly what we predicted, right? A factor of 0. I'm sorry, x minus 1 is a factor, means you get a remainder of 0. If you didn't get a remainder of 0, you would have to check your work because you did something wrong, right? You made a little mistake somewhere. All right. Now I have so far that our quotient is a 2x squared minus x minus 6, right? And then that's one of our factors. The original factor that we were given was x minus 1. So now I have that f of x is equal to this, right? Now you just want to check and make sure that the inside is factorable, right? Let's just see if we can factor 2x squared minus x minus 6, right? And again, quadratics are super easy. You just have to do 2 times -6. And then we do -12, factors of -12 that add to -1 is a -4 and a 3. So this is factorable, right? So then we would get an x, an x minus 4 and an x plus 3. All right, there is a 2 in front, so I'm going to divide by 2. And then if it divides, we're going to divide it. It's going to be x minus 2. And then we can slide that 2 up front, 2x plus 3. So those are the factors that we get from this quadratic. And then I just want to bring down the x minus 1. And then if you look at each of our factors, none of them can be factored any further. So this is our answer in factored form. All right. Again, we just took something that would otherwise be unfactorable, something like that, and we factored it, right? So we were only able to do that with synthetic division, right? So it's super important that you guys know that. This isn't part of the question, but I just want to say, like, let's say you had a part of the question that said find the zeros. Find the zeros of f of x, right? Which seems like it would be its own process, but it's really the exact same thing, right? Now that I have the factored polynomial, all I have to do is set all of my factors equal to 0. So x minus 1 equals 0, x minus 2 equals 0, and 2x plus 3 equals 0. Right, so this is just extra stuff for you guys because you guys are going to run into problems that are going to ask to find the zeros, find the factors, and find everything that some of these questions get kind of intense, right? There's a lot of parts to them. And you get x equals negative 3 halves, right? So then these are our 3 zeros, which is consistent with what we expected from the beginning, because if you remember from a while ago, the highest exponent should tell you the amount of solutions that you should get, right? And we got 3 solutions, and we also got 3 factors. All right, we can try the exact same thing here. All right, so I'm given that x equals negative 5 is a 0, so then I know that when I do synthetic division, we get 0 as our remainder. So let's just do our synthetic division. And then I'm going to bring down 6. 6 times negative 5 is negative 30. I get a negative 13. I get a 65, a positive. I get a 2. I get a negative 10, and then a 0. All right, so that is what we expected. And now these are going to make the coefficients of our quotient. So this is going to make a 6x squared minus 13x plus 2 equals 0. Or we don't have to write the equal 0 because we're just asked to factor. And then let's do 3 times 2. So factors of 12 that add to negative 13 are negative 12 and a negative 1. So I'm going to do x minus 12 times x minus 1, divide by 6. All right, and then we get x minus 2 and 6x minus 1. All right, so this is this part in factored form, but if I want my entire f of x in factored form, right, keep in mind I need both of these that I just found. So x minus 2, 6x minus 1. And I need the original that we were given, right? And again, if x equals negative 5 is a 0, that's the exact same thing as x plus 5 is a factor. So that means I need to include that x plus 5 in my final answer. So then that's my factored expression, or factored polynomial. Let's say I asked to find the zeros, right? So let me do that down here, right? Find the zeros. Right? From here, it's easy, right? All you have to do is take all of your factors and set them equal to 0. So x minus 2 equals 0, 6x minus 1 equals 0, and x plus 5 equals 0, right? We were given negative 5, so don't have to do much there. And then we get x equals 2, and then we get x equals 1/6. So then I get 3 zeros here, which is consistent with our highest degree, right? If you remember way back, right? The highest exponent should tell you the amount of solutions that you should get, right? So we do get 3 answers here. And similarly, we get 3 factors here, all right? So that's our solution, or that's our polynomial in factored form, and those are the zeros. All right, so hopefully so far it's not too bad, right? You can see that it's a bit of a process to get our polynomial in factored form. But since we were given zeros, or we were given a factor, then it made it a little bit easier to kind of to factor the rest of our polynomial, right? But let's just say, and in the examples moving forward, we're not going to give you a factor, or we're not going to give you a 0. You're going to have to figure out what your factors and what your zeros are completely from scratch, right? Now that's going to be a bit of a process, right? It gets pretty tricky, all right? But we do have a process for it. Right, and now the process is you're going to put your polynomial in decreasing exponent order, right? So put it in standard form, and then you're going to find the possible roots by having, right, we're going to narrow it down, right? And what this means, plus minus the last over the first, it's factors of the last term over factors of the leading coefficient, right? Or the first term, right? So it's just factors, right? All of the factors, right? It's not just the last number over the first number, right? It's all of the possible factors. Now, what this does, right? What this process does is it narrows down our possibilities, right? If you were to do synthetic division, right, that entire process for every single number, right, you would be working on a single problem for a really long time, probably, until you find one that works, right? So instead of blindly guessing, instead of blindly picking numbers to test, right, this gives us a little pool of possibilities, right? So we have maybe some numbers that are going to work, and although it might narrow it down nicely, sometimes you get a couple numbers, maybe like 4 to 8 possibilities to choose from. Sometimes you get like 20, right? Numbers that you have to test, right? And not always are you going to have to test that many numbers. But I will say it's better than just blindly picking and not knowing if it's going to work or not, right? So it's better to give yourself that pool of possibilities, right? And that's what that last little bullet means, right? This little asterisk right here. To find all the roots, you're going to test the possible roots until you find a remainder of 0, right? And you're going to do synthetic division. And this is what I was saying in the previous lesson, that sometimes in some problems, you're going to have to do synthetic division like 3 times, 4 times until you get a number that works, right? Which gets tedious, but you're going to only test the possible ones until you get a remainder of 0. And then you keep going until you can factor it nicely. So either like we did before, or if it can't factor at all, just use quadratic formula to find the remaining roots, right? And I'll show you what that process looks like now. All right, so this is our process, right? I want to find all of the zeros, right? We're not given any other information other than our polynomial, right? And if you tried grouping, right, I know it has 4 terms, but you can't group this, right? What you would do instead is you would test numbers to see if they work, right? Sometimes you get numbers that work, some don't. But to find out all the possible roots, right, I'm going to do that first right here, right? I'm going to list out all of my possible roots. And my possible roots are going to be plus minus factors of the last, so plus minus factors of 15. You don't have to worry about carrying the negative with it just because we account for that with the plus minus, right? Over factors of our leading coefficient over factors of our first, which is 8. And so let's actually write those out, right? This is going to be plus minus factors of 15. Factors of 15 are 1, 3, 5, and 15. Factors of 8 are going to be 1, 2, 4, and 8. All right, so we have all of these possibilities to choose from. Now, the way it's written like this, it might look a little confusing, right? What numbers can we actually pick from? Well, I'm going to write it out off to the side over here. I'm first going to start with writing everything over 1, right? So I'm going to put everything on top over 1. So I'm going to have 1 over 1, right? 3 over 1, 5 over 1, and 15 over 1, right? Now I'm going to put everything over 2. All right, so I'm going to put 1 over 2, 3 over 2. Whoa, that looks, hang on. Yeah, 3 over 2, 5 over 2, and 15 over 2. All right, now I'm going to put everything over 4. All right, so I need 1 over 4, 3 over 4, 5 over 4, and 15 over 4. All right, and now I'm going to put everything over 8. So I'm going to have 1 over 8, 3 over 8, 5 over 8, and 15 over 8. Right? All of these are plus minus, by the way. Like plus, so I can use the positive one or the negative one. Right? And with everything over 1, just to make it easier to read, I'm going to simplify all of these. Right? 1 over 1 is just 1. 3 over 1 is 3. 5 over 1 is 5. And 15 over 1 is 15. Right? So I'm going to make this 5 and 15. Right? So these are all of my possibilities. So I have, looks like 16 positive and 16 negative. So really you have 32 possibilities to choose from, right? And if you're super unlucky, right, you might have to test it 32 times, right? That's like astronomical though, right? You're not really gonna get ones that you're gonna have to test probably more than 4 or 5, right? Something like that. All right. Sometimes it even works on the first one, right? But now this is the point where we check which ones actually work. All right. Now this is the part that gets really tedious, right? Because you're going to check numbers and then you're going to find maybe some of them don't work, and then you're going to have to keep repeating the process until you get one that works. But I will say it's better to have this limited amount of possibilities rather than like an infinite amount, right? It's better to check 1, 3, 5, 15, right? Those kinds of numbers instead of doing like 1, 2, like let's say, for example, you checked 4 for some reason, right? 4 isn't even in one of our possibilities. So I know I shouldn't check that, right? We have a limited amount to choose from, which helps us, all right? So now we start a little bit of trial and error, right? So I'm going to pick easier numbers to choose from, right? I'm not going to start my synthetic division with like 1/2, right? Or 5/4 or anything like that. I'm going to pick an easy number like 1, right? Because that's one of our possibilities, right? That's one of them, right? +1 and -1. So I'm going to try +1 first. Let's see if it works. And I'm going to do my synthetic division, right? This is where the trial and error starts. So 8, 50, 47, and -15, right? These are our coefficients of our function. So start the process. 8, 8, 58, 58. And then you're going to see, like, when you add this, like, once you start getting, like, a big number, like 105, and you get 105 minus 15, that's not going to get you 0, right? The goal here is for this number to be a 0, right? So I know that this does not work, right? Didn't work, let's try the next one, right? The next best thing to check is -1, right? Maybe you get a negative number that works. So I'm going to try 8, 50, 47, and -15. Let's just see if -1 works. All right, so I'm going to bring down 8. I get -8, 42, -42, 5, -5, and then I get -20, right? That's not 0, so it doesn't work, right? And then I'm sure you guys can see from now that this actually gets pretty tedious if you have to get like really complicated stuff. Let's try 3, right? 3 is the next best number, right? We're still going to use our integers. I don't want to use a fraction unless you have to, right? We're going to do 8, 50, 47, and -15. All right, now let's see if 3 works. So we're going to get 8, 24, 74, and then maybe you guys can see from now that this isn't going to work, right? 3 times 74 is a really big positive number, and then we're going to get another really big positive number, and then positive times 3 is going to get us another really big. You can even try it if you want to, but I know that this isn't going to work. All right, let's try -3. All right, so again, 8, 50, 47, and -15. Let's just see if this works. All right, bring down the 8. 8 times -3 is -24. We get a 26. 26 times -3 is a -78. I get a -21. And then I get a 63. And then you can see that this isn't going to work. Right? As soon as you see that it doesn't work, right, you don't have to keep going and just see what number it is because you're really looking for 0. All right, let's try 5 now. All right. So you can see all the work that we're doing so far. I mean, I would hope that one of these would work at some point, right? And in theory, it should because these 5 is one of my possible roots to choose from, right? 40, 90, and you can see we're already getting into huge numbers, 450, and there's no way that that's going to get me 0 at the end. So that also doesn't work. I'm going to go ahead and erase some of this stuff here just so that I have a little bit more room. All right, let's erase that. Let's try 5. I think, if I remember correctly, let me put that number back. If I remember correctly, -5 does work, right? Let's just verify that it does. So I get an 8, a 50, a 47, and a -15, right? Let's just see what this gets us, right? Bring down the 8, you get a -40, a 10, -50, -3, and then 15. It does work, okay? Finally, right? We got something that works. So what I know for sure is that x equals -5 is one of my zeros, right? So it is one of them. If we did synthetic division and it worked, then that's one of my zeros. So then what we can do from here, instead of continuing to guess and check, is I would take this, what we have left over, and we would write that as its own separate polynomial, and then we would set that equal to 0 and solve that, right? Now remember, this, if there's a remainder of 0, that means this is our quotient, this is the rest of our factors. So then I can take 8 and put it in front of an x squared, 10, put it in front of an x, and then take the -3, and then set this equal to 0, right? Just because once we took out the x equals -5, this is what we have left over, all right? So let's just see if this factors, right? So let's do 8 times -3, I get a -24. And we need factors of negative 24 that add to 10, and it's going to be a 12 and a negative 2. So it does work. It does factor, right? So it's going to be an x plus 12, x minus 2 equals 0, right? There's an 8 in front. Don't forget to divide by that 8. I would hope at this point we don't make silly mistakes like that. This is going to simplify to 3 over 2. Bring over the 2. It's going to be a 2x plus 3. All right. And then 2 and 8 simplify. And that's going to get me a 1 over 8. I'm sorry, a 1 over 4. And so this is going to get me 4x minus 1 equals 0. And then you can set both of these equal to 0. So I get 2x plus 3 equals 0. And then 4x minus 1 equals 0. And so we get x equals negative 3 over 2. And then x equals 1/4. And then those are the zeros of our polynomial, which makes sense because our highest exponent is 3. So we should get 3 zeros. Now, keep in mind, negative 3 halves and 1/4. If you look at our possibilities, right, remember it's plus minus everything, right? So 1/4 worked, and so did 3 halves. Those were in our possibilities. So if we kept going with our synthetic division, let's say you didn't know that you had to write this and factor it, then you would have been stuck doing this for a really long time using fractions in your synthetic division, and it gets nasty, right? So just, you need to recognize from the beginning that as soon as you get something that works, you need to immediately reduce it, right? I don't want to take my original polynomial and then keep trying numbers, because let's just say this wasn't factorable, right? If it wasn't factorable, I would have had to use quadratic formula and nothing would have worked, right? I wouldn't have been able to get my answers the way that I did here. All right, so that's just something to keep in mind. All right, let's try the exact same thing with the next one, right? You guys are probably seeing that this gets a little bit tedious, right? But let's just try it. The first thing that we do is we find possible roots, right? And again, the possible roots are going to be plus minus factors of the last over factors of the first. Now our last number is 2. Factors of 2 are just 1 and 2. Over factors of the first, our first number is 6. Factors of 6 are 1, 2, 3, and 6. Now again, I want to write this out fully, right? I want to see all of my possibilities. And that's going to give us something over 1, right? So I'm going to get a 1 over 1, 2 over 1, right? Put everything over 2, 2 over 2. I'm sorry, 1 over 2 and then 2 over 2. But 2 over 2, you're going to see that that simplifies to 1, right? I'll keep it there for now. Right, let me actually write that a little better. 1 over 2, 2 over 2. All right, and now let's put everything over 3, right? 1 over 3, 2 over 3. And now let's put everything over 6, right? 1 over 6 and 2 over 6. All right. Now, when you simplify things fully, right? 1 over 1 and 2 over 1, that's just going to get you a 1 and a 2, right? 2 over 2 now, that's going to get you 1, right? And if it repeats, you don't have to write it twice, right? So I can get rid of 1 altogether as one of my possibilities, all right? And then the other thing that simplifies is 2 over 6, right? 2 over 6 simplifies to 1/3, but I already have a 1/3 right here, right? So then I'm just going to erase 1/3. I don't need to test it twice, right? So then really we only have plus minus these 6 possibilities, right? So really we have 12 options to choose from, right? So simplifying, you're going to see, really narrows down some of your possibilities, right? Let's actually try testing now, right? So we found our possibles, right? This is our pool of possibilities that we have to choose from. Now let's actually see which ones work. Right, so this is the trial and error part of it. So I'm going to test 1, right? Test the easy numbers first. Don't try to go head first into like fractions and things like that. I'm going to do 1, and then we get a 6, a 7, a negative 12, a negative 3, and a 2. All right. Bring down the 6. All right, times 6, add this, we get 13. We get a 13 here, a 1, a 1. We get a negative 2, and we get a 0. So actually 1 worked, right? If 1 worked, I can immediately circle that as one of my zeros, right? So that's good for us, right? It actually makes things a little bit easier. Just notice now that our quotient here, right, is going to be 6x to the third plus 13x plus x minus 2. I can't factor that still, right? I still can't factor that. You can try to group it, but you're not going to get a GCF, you're not going to get matching parentheses. So really, we're going to have to keep repeating this process using the same information that we originally had, right? The only thing is I don't want to use this entire thing first. Now that we've narrowed it down to be this as our remaining factors, I'm going to use these coefficients as our numbers for synthetic division, right? So I'm going to use the 6, the 13, the 1, and the -2. And then hopefully you see that that's a lot easier than using these numbers up here, right? I don't have to use these numbers again if I already found one that works, right? I only have to do with whatever's remaining, right? And thankfully we have the exact same possibilities. We have the 6 and the 2, all right? So let's just pick a number again, right? Now, one thing to note, I would still pick 1 again, right? And just because if it works once, that doesn't mean that it's not going to work again. It might work again, right? You might just have an answer twice, right? So let's just check 1 to make sure that this isn't the case, right? Let's just verify, right? Bring down the 6. I get a 6, a 20. I'm sorry, not a 20, a 19. And then this gets you 20. And then you're going to see that this doesn't work. All right, so I can immediately erase this, right? Let's try -1. All right, so -1, I'm going to bring down 6. I get a -6, right? 13 minus 6 is 7. Then we get a -1. And then you're going to see that this doesn't work, right? We get a 6 up here, and that doesn't work. So let's erase that. Let's try now, what's another possibility? 2. All right, let's try 2. All right, and so trying this with 2, right, we get a 6, a 12, a 25, a 50, and then you're going to see that this is going to get us really big numbers. Well, not outrageously big, but it's for sure not 0, right? So let's try a -2 now. All right, bring down the 6. We get a -12, a 1, a -2, a -1, a 2, and then a 0. So it does work, right? So that means x equals -2 is another one of my zeros, right? I already found 2 of them. All right, let me just separate it from that problem. All right, I already found 2 of my zeros, right? Now let's see if what we have left over with the 6, the 1, and the -1, let's see if that factors, right? 6x squared plus x minus 1 equals 0, right? Factors of -6 that add to 1 are going to be a 3 and a -2. So it does factor, right? We get x plus 3, x minus 2 divided by 6. And then we get, right, 2x plus 1. And then we get, this simplifies to 1/3, so 3x minus 1 equals 0. And then so I get 2 more zeros, which are x equals -1/2 and x equals 1/3. All right, so then we get all of our zeros here, right? We get 4 total, which makes sense because our highest exponent was 4. All right. All right, a couple more. Let's try them the same way. All right, so first with number 6, I want to list out all of my possible rational roots. So it's going to be plus minus factors of the last, which is a 5, so 1 and 5, over factors of the first, which is 1, right? So we really don't have a lot of options here. This is going to be a 1 over 1 and a 5 over 1, right? Which really, that's just going to get us 1 and 5. So it's going to be plus minus 1 and 5, all right? Now I'm just going to test, right? Let's just test 1, right? Let's pick an easy one, all right? When we pick 1, hang on. Sorry, I'm charging my iPad and it's making the pencil glitch. Okay, so 1, and then I have a 1, a 4, and then keep in mind I need a spot for the x, so I'm going to have a 0 as the placeholder, a 1, 4, 0, and a -5. All right, so I'm going to bring down 1, and what goes up is going to be a 1. 4 plus 1 is 5, times 1 is 5, bring down a 5, and then this is going to go up to 5. And then we get a remainder of 0, right? So we actually got kind of lucky here, right? We got x equals 1 works, all right? And then now we can use these leftover numbers as coefficients of our quotient. So this is going to be an x squared plus 5x plus 5 equals 0. And we want to check if we can factor this, right? So factors of 5 that add to 5, it actually doesn't have any, right? So this is a pretty unfortunate case where we actually can't factor it. We're going to have to use another method, right? Quadratic formula, or completing the square if you need to, right? Our b is odd, so I'm not going to use completing the square. I would probably just use quadratic formula. So I'm going to do x equals negative b plus minus the square root of b squared minus 4ac over 2a. All right, and then we simplify as much as we can. We get negative 5 plus minus the square root of 5 squared is 25. 4 times 1 times 5 is 20. 25 minus 20 is 5 over 2 times 1 is 2. Right, and there's no way to simplify that anymore, so I get x equals negative 5 plus minus the square root of 5 over 2 as my final answer. Right, so we get 3 zeros, we get 1, and then plus minus means that there's 2 answers, right, which is consistent with our highest exponent. All right, let's try the same thing with the next one. All right, so factors of 3 over factors of 1, right, so it's going to be plus minus 1 comma 3 over 1, right, and that's going to be plus minus 1 and plus minus 3, right, so we really get 4 options to pick from. Again, let's pick the easiest one, so 1, and then I get a 1, a 0, a 2, and a negative 3. Again, be super mindful of any missing variables, right? I'm missing an x squared, so I need a 0x squared. All right, bring down 1, up goes 1, we get a 1, a 3, and then a 3, right? So again, we got kind of lucky, right? 1 works. So we get x equals 1. And then these are going to become coefficients of our quotient. So x squared plus x plus 3 equals 0. Again, we actually can't factor this, so we need to use quadratic formula or complete the square. Right? I'm going to use quadratic formula. I get x equals negative 1 plus minus the square root of 1 squared minus 4 times 1 times 3 over 2 times 1. This is going to get me a negative 1 plus minus the square root of 1 minus 12 over 2. And that's negative 1 plus minus the square root of negative 11 over 2. And that negative 11 is I, right? So this becomes negative 1 plus minus I square root of 11 over 2. So we actually get imaginary solutions here, right? So on a graph, this might look like some sort of curve where it doesn't cross the x-axis, right? So there's only one part that it crosses the x-axis and it's at 1. So it might be something like that, right? I actually don't know what the graph of this looks like, but that's going to be the next lesson, right? So I know for sure that maybe this, we don't know, right? It might go something like that, where it only crosses 1 point, right? But it might have little curves here that go out as well, right? So that's one instance where the zeros that we get might not be real. But that doesn't mean they're valid solutions, or that doesn't mean they're not valid solutions, right? They're just imaginary. Just be careful with some directions, right? I think on your homework, there's a couple problems that say find all real zeros, right? And if it says find all real zeros, the only one that you would count here is this one right here, right? You wouldn't even look at that one, right? But for the sake of this example, we can just list all of them. All right, very last one. So what we're going to do is the same exact process as always, right? So we need to find all the zeros, but we're not really given any other information than this polynomial, right? So what I have to do is find a list of all the possibles. So in this little dark blue space right here, I'll list those out, right? It's going to be plus minus factors of the last over factors of the first. So 1, 2, 4, and 8 over 1. Right, but anything over 1 is itself, right? So I'm just going to get rid of this, and it's just going to be 1, 2, 4, and 8 as our possibles, right? So what I'm going to do, start with 1 and see if that works, right? 1, 0, right? We need a 0 because I don't see an x to the 4th in my polynomial, but we need a placeholder for it. So 1, 0, 1, 2, negative 12, and 8. And then we do our synthetic division, right? Bring down 1. 1 times 1 is 1, 0 plus 1 times 1 again. It's going to get us a 2. We get a 2, a 4, a 4, a negative 8, and then a 0. All right, so x equals negative 1 is one of our zeros. All right, so let me just write that over here. Circle it so you don't forget it. All right. And if you write a polynomial using these as your coefficients, you're going to see that you're not going to be able to factor it, right? So something like this, right? Our highest exponent is 5, which means our exponent of our quotient is going to be to the 4th power, right? 1 degree less. All right, plus 4x minus 8 equals 0, right? We can't really factor it, right? There's 5 terms here. We can't really group it or take out a GCF or anything like that. So what we're going to do is we're going to do synthetic division again using these as our coefficients, right? I don't want to start from the beginning using these numbers, right? Because that's, right, if we can narrow it down to just a few like we do here, then that's going to be ideal, right? So I'm going to do the same thing. I'm still going to use 1, right? Just because 1, even though it worked once, it doesn't mean it can't work twice, right? So let's just try it. 1, 1, 2, 4, and negative 8. Let's just see if negative 1 works again. I'm sorry, not negative 1, right? Let's see if 1 works again, right? Bring down 1. We get a 1, 2, 2, 4, 4, 8, and 8, right? And it does work again, right? Look at that, right? We get another x equals 1 as our answer, right? So 1 worked twice, right? And these numbers here represent the coefficients of our quotient, which is going to be x to the 3rd plus 2x squared plus 4x plus 8 equals 0. And this actually does look like we can factor it now, right? If I tried grouping it, we would take out an x squared. We would be left with an x plus 2. We can take out a plus 4. We'd be left with an x plus 2 equals 0. And so we end up with x squared plus 4 and x plus 2 equals 0. All right, so then I get x squared plus 4 equals 0 and x plus 2 equals 0. And so we get x equals negative 2. And then I get x squared equals negative 4. Square root both sides. And so I get x is plus minus 2y. All right. So we actually do get the 5 answers that we were expecting, right? Our highest exponent, again, tells us how many answers we should get. We get x equals 1 twice, a negative 2, and then plus minus 2y, right? And you're going to learn in the next lesson, the next lesson, 3.2, that these numbers actually have meaning on a graph, right? So if you get a number that shows up twice, right? So the 1 and the 1 right here shows up twice. Let me make a note of this. Twice, right? That means it's going to have a multiplicity of 2. Multiplicity of 2, right? Multiplicity just tells you how many times your answer appears. And depending on if it's an even or odd number, right? So in this case, it's an even multiplicity that has meaning on a graph as well, which we're going to explore more in the next lesson. All right, but that's it for this lesson where we actually solve these equations.